A uniform beam of length 7.5 meters and weight 3.65 times 10 squared, which is 365 newtons. Doesn't seem like that heavy of a beam. That beam definitely looks heavier than 70 pounds. It's carried by two workers, Sam and Joe. Man, is that an I-beam? Massive. Sam and Joe, as shown in the figure below, determine the force that each person exerts on the beam. All right. So first thing we're going to do is draw a picture. Picture is sort of drawn for us, but we want to free body diagram it. So we want to look at the forces involved here. So I'm going to say the force involved is here. Yes, let's go with that one. And then we're going to have two forces. We're going to have force Sam going up, and we're going to have force Joe going up. From here then, what we're going to do is, if this was, so let's look at this from a Newton's law point of view. So the sum of all forces equals force Sam plus force Joe minus, I'll call this force gravity. Minus force gravity equals 0. And the idea there is there's no acceleration up or down. And so when we add up all the forces, we're going to get 0. Newton's second law. Force equals sum of all forces equals mass times acceleration. Now, to carry that concept further, we can say something very similar about torques. The sum of all torques is also going to equal 0 because it's not rotating. So this is going to get a little bit more nuanced. So what we're going to do is we choose a pivot point. So you can really choose any pivot point you want. Really, what you want to do is find a pivot point where one of the torques cancels out. So what we're going to do here is we're going to choose, torque is R cross F. So it's the cross product of the moment arm, the distance, perpendicular distance from the axis of rotation, times force. And so if we get a distance of 0, R equals 0, then that force doesn't matter. It doesn't create a torque. So what we're going to do is we're going to choose Sam as the pivot point. Therefore, Sam is not going to create any torque about that point. But now what we're going to do is we're going to do the sum of all torques. I'm going to call this torque left. I'm going to call this torque right. I'm going to call this torque Joe. So torque Joe, he's going to be pulling it this way, which is counterclockwise. Torque right is going to be pulling it down, because torque right is the mass of the bar to the right of Sam, pulling it down, so that's going to be clockwise. And then the torque on this side is going to be, on the torque left, is going to be counterclockwise as well, because it's the left of the pivot point. So what I mean by clockwise and counterclockwise is they oppose each other, which just means they have to have opposite signs. So I'm going to say torque left plus torque Joe minus torque right equals 0. Torque equals R cross F. Cross product is its measure of how perpendicular two vectors are. Since the R in this case is going to be along the beam, and force Joe and gravity are either up or down, they're 90 degrees from each other. So in this case, it's going to be R times F. So, and then, let's see, torque left, that's going to be R left. So I'm going to call this R left times mass left plus R Joe, force Joe, minus R right mass right. So we don't really know the mass of, so we know the weight. Oh, sorry, this should be mass times gravity. Oh, sorry, these are not supposed to be masses, these are supposed to be forces. So force left, force right. And so when we go back to this picture here, I know it's getting kind of cluttered. When we have this bar, the R left is going to be halfway. We're going to assume that the center of mass of this bar is halfway in the middle there. So that bar is 1 meter long, so RL is going to equal 1/2 meter. So force left is going to be the proportion of the entire bar. Oh, we're going to get rid of some of the mess here. Whoop. So the entire length of the bar is 7.5. So it's going to be the portion of the bar that's to the left. So it's going to be 1 meter over 7.5 times the total force, which is going to be 365. And the idea is it has a constant density, constant linear density. Therefore, if you have 1 over 7.5 of the length of the bar on the left side, then it's going to be 1 over 7.5 of the total mass, which is going to be that much of the gravity. Similar for the right, our right, we have a distance on the right of, if that was 1, there's going to be 6.5. So that's going to be 6.5 over 2. That's going to be the distance. Let's see here. This distance is 6.5. Yep. And so then halfway in the middle of that, 6.5 over 2 is going to be the center mass where the torque is going to act. And you can do that with any like linear uniform bar. So then force right is going to be 6.5 over 7.5 times 365. 365 is just the weight, the force due to gravity. And then R Joe is going to be the distance of Joe from the axis. We said the axis of rotation right here was Sam. So the distance between Sam and Joe is going to be 6.5 minus 2. So this distance right here is going to be, so this distance right here is 6.5. 6.5 minus 2 is going to be 4.5. So R Joe is going to be 4.5. All right. And we know that the sum of all torques are going to equal 0 because this is not accelerating angularly. It does not have an angular acceleration. All right. So now we're going to put all this together and see what we can find. We want to solve this for force Joe. We might actually have enough info from this equation just to solve for force Joe. Let's go for this. Let's see if this works. So force radius Joe, force Joe is going to be radius right, force right, minus radius left, force left, all over radius Joe. I know this is terrible boardsmanship. Oop. Let's divide both sides. Maybe we can do this. Maybe we can do this. So radius right, 6.5 over 2 times force right, which is 6.5 over 7.5. I could probably simplify things here, but I'm not going to because I don't think I have to. Minus radius left, which is 1 over 2, times, let's see here, 1 over 7.5 times 365. Yep, because that's force left, all over radius Joe, which is 4.5. I should simplify that a little bit. So it's going to be 365 over 2 times 7.5 times a quantity, 6.5 squared minus 1 squared, all over 4.5. Maybe. Let's put this into a calculator and see if this gives us something that looks almost reasonable. So we're going to have 365 divided by quantity 2 times 7.5, and that whole thing is going to be multiplied by 6.5 squared minus 1, also squared, divided by 4.5. And I got an answer of 223.05. Force Joe. That seems possible. That seems very possible. So let's see here. Yeah, it looks like Joe is more towards the center, so he would probably carry more of the weight. All right, so now I'm going to do the exact same thing. Yes, I'm going to do the exact same thing, but now I'm going to say the pivot point is at Joe. So we're going to rewrite this again. So the sum of all torques. So this is our new pivot point. This is going to be torque left. This is going to be torque right. This is going to be torque Sam. So torque Sam is clockwise, torque right is clockwise, and torque left is going to be counterclockwise. And I'm just doing the directions there to make sure I get my signs correct. So I'm going to say that the sum of all torques is going to be equal to 0, but also then we're going to have torque Sam plus torque right minus torque left equals 0. That's going to be R Sam, force Sam, plus R right, force gravity right, minus R left, force gravity left. Seems plausible. Seems plausible. R Sam is going to be a distance from the pivot point, so it's the distance between Sam. So this is, let's see, this is this holding is 7.5, 1 meter. Yep, 4.5. I think I said that last time too. Yep, R Sam is 4.5. Force Sam equals question mark, because that's what we're trying to find. Radius right is going to be 2 divided by 1. Force gravity right is going to be 2 over 7.5 times 365. Radius left is going to be, so 7.5 minus 2, 5.5. 5.5 radius right is actually going to be 2 over 2. There we go. That makes sense. I think I wrote the 1 because I'm like 2 over 2 is 1. Fail. 5.5 over 2, so it's going to be the midpoint. And then force gravity, that's supposed to be a G right there. Left equals 5.5. I know, a little bit messier than I should be. Part of life, I suppose, times 365. All right, so now we got all the variables down there. So we have radius Sam, force Sam equals radius left, force gravity left, minus radius right, force gravity right. Therefore, force Sam is radius left, so 2 over 2 times 2 over 7.5 times 365. Yes, minus radius right, which is, this is supposed to be, which one of these? This is supposed to be radius right. What did I mess up here? These are supposed to be negative. Whoop. Tragic fail. So 5.5 over 2 times 5.5 over 7.5 times 365. There we go. This is force gravity. This is the torque left. This is torque right. And do I have that backwards? Nope, because it should be force Sam equals left. Yep, I'm good at this. Maybe. We will see. And this is all going to be divided by radius Sam. Simplifying things, we should get the same thing we did earlier. Yep. 365 over 2 times 7.5 times 5.5 squared minus 2. No, yeah, 2 squared. All over radius Sam, which we said was 4.5. So I'm going to go back up to our previous. So 365 divided by 2 times 7.5, and this time we're going to have 5.5 squared, and we're going to have 2 squared, and the distance between them will still be the same of 4.5, and I get an answer of force Sam equals 153 newtons. So bring this down, move this over, 153. So here's our equation. Maybe, we'll see. All right. So the answer is 153 and 223. 153, 223 newtons. So going back, one thing I want to do before I finish this one off is we can go back to our first equation up here where we said that the sum of all forces, F equals ma, have to equal out. So if I do 153 plus 223, 153 plus 223, we add those together, we get, hopefully, 376. 376. Weird. Is that true? So 152, 223. I'm going to check the other one real quick, make sure I didn't do something too obviously wrong. 6.5 squared, 1 squared, or 4.5. Yeah, 223. So, was that a rounding error? I think I might have done something somewhere wrong. Because what's supposed to happen here is, you look at the thing real quick, 1.5, 6.5, those added up. Yeah, maybe. Maybe. So the idea here would be that the force due to Sam and force due to Joe also have to lift up together, and those have to equal force gravity of the beam going down. And so what I was expecting to get was 365 exactly for the weight coming forward. What that also means is that I didn't actually have to go through to find the force Sam. I could have gone back to our original equation, force Sam plus force Joe minus force gravity equals 0. And so, since they give us force gravity, we found force Joe, we could have found force Sam, which I expected to be 365 minus 223, which would be in about 142. So, might have made a mistake somewhere, but maybe it was a rounding error. Let me check this real quick. 5.5 squared. That's supposed to be 2 squared or 1 squared? No, it's supposed to be 2 squared. That's exactly what I did wrong right there. It is supposed to be 142. Hop! 142. Put it in the calculator wrong. Fail. So that's why you should check things. 142, and then this answer is 365. So yes, everything was wrong. Everything was correct. Put in the calculator wrong. Bush League Amateur. So to recap what we did here, I know, terribly confusing. We redraw this as, we look at this as an axis. So one axis is going to be Joe's hand. So we have force Joe going up. We're going to say that this is the axis of rotation. Is Joe on the left? Joe on the... Sam is on the left. I know, doesn't matter. Force Sam, force Joe, and then we're going to have the gravity due to the beam. We're going to have a force gravity left side, force gravity right side. And since this is an even beam right here, we just do it at the halfway point on the beam here. So we look at, this is one beam, this is another beam. Center of gravity, center of mass is at the center. Those forces, which are perpendicular to a moment arm, so this is the axis, these are the moment arms. We say the sum of all torques, which is going to be, if this is the pivot point at Sam, this is going to be torque Joe plus torque gravity left minus torque gravity right. As it is not rotating, this all has to equal 0. We say torque equals R times F in this case. It's a cross product, but we simplify this to R cross F. We plug in numbers and we just algebra our way through it, brute force math. So, and that's how we get the answer. That's how we get this one. This is a challenging question, but once you get the concept down, you're like, all right, it's more cumbersome. And the concept isn't too bad. So, hope that helped. See you on the next problem.